Hi, I hope that you are doing great in your personal life by the grace of God. In this AV, we would be solving some of the numericals from exercise 2C of the chapter Motion in One Dimension. This is the exercise that we are talking about, exercise 2C and the numerical part. So I have already written some of the numericals that we would be solving. To start with, let's try and solve the first question, which states that a body starts from rest with a uniform acceleration of 2 meter per second square. Find the distance covered by the body in 2 seconds. So first of all, we will write all the given things. Given, they say that the body starts from rest. That means the initial velocity, that is u, is 0, and then with a uniform acceleration of 2 meter per second. So acceleration, that is a, is 2 meter per second square. We have to find the distance covered in 2 seconds. So we know, or you can write from the equation of motion, S equal to ut plus half at square, where S is the distance, or you can write, before writing you can just write that let S be the distance covered by the body. So we know S is equal to ut plus half at square, where S is the distance covered, u is the initial velocity, t is the time taken, a is the acceleration, and t again is the time taken. So here, from the given things, we know that initial velocity u is 0. So this entire term, 0 into time, is 0 plus half into acceleration is 2 meter per second square multiplied by time square. So here they have given the time to be 2 seconds. I have not written here, I'm just writing it here. Time is 2 seconds. So in place of time we write 2 square. So half multiplied by 2 square is 4. So that is equal to 2 and 2 cancel out. We have 4 as the answer. So unit of distance is meter. Therefore distance S is equal to 4 meters. Now we go to question number 3. We will try to solve at least one question of each type. Question number 3 says, a vehicle is accelerating on a straight road. Its velocity at any instant is 30 km per hour. After 2 seconds, it is 33.6 km per hour, and after further 2 seconds, it is 37.2 km per hour. Find the acceleration of the vehicle in meter per second square, and is the acceleration uniform? So first we write the given things like before. So what are the given things? So we have written that the velocity is 30 km per hour. Here what we have to keep in mind is we have been given 2 instances. That is, first the vehicle is moving with 30 km per hour. After 2 seconds, the vehicle is moving with 33.6 km per hour. And then after 2 seconds, it becomes 37.2. So first, we will take these two. So in these two, our final velocity would be 33.6 and initial velocity would be 30 km per hour. Using this, we will be calculating the acceleration. So here we know that acceleration A is equal to change in velocity. Change in velocity means final velocity minus initial velocity divided by the time taken. So for the first part, this is the final velocity, that is 33.6, initial velocity is 30 and time is 2 seconds. So using these values, we have 33.6 minus initial velocity is 30 divided by time taken is 2 seconds. So from here 33 minus 30 is 3.6 seconds divided by 2, we get 1.8 kilometer per hour square. Now we have to convert it into meter per second square. So to convert in meter per second square, what we do is we simply multiply this 1.8, we simply multiply it with 5 by 18. Okay, so we will get, these two will cancel out, and then point, so 0.5 meter per second square. Now this is the acceleration. In the question they have asked us to find the acceleration. So this is the acceleration. The second part of the question says, is the acceleration uniform? So we will find the acceleration again for these two cases. So the next case, 33.6 km per hour will be our initial velocity, time will be 2 seconds, and 37.2 will be our final velocity. So case 2, we have acceleration A is equal to final velocity, that is V, minus initial velocity upon t, time taken. So here the final velocity would be 37.2 minus the initial velocity would be 33.6 according to the question. And so here, after doing the calculation, it will come as 1.8 kilometer per hour square. Again, if we convert it into meter per second, we will be multiplying it with 5 by 18, and the answer would be 0.5 meter per second square. So here we see that in case 1 the acceleration is 0.5 meter per second square, and in case 2 also it is the same acceleration. We are getting the same value of acceleration. So therefore we can say that yes, the acceleration is uniform. Now moving on to the next question, that is question number 4. It says a body initially at rest. So we will directly start writing the given things. Initially at rest, that means initial velocity u is 0, starts moving with the constant acceleration of 2 meter per second square. So acceleration A is 2 meter per second square. We have to calculate the velocity acquired and the distance traveled in time 5 seconds. Now what we can do is, for the first part, using the formula for acceleration, we know that acceleration is equal to v minus u, that is final velocity minus initial velocity divided by time taken. So from here we can write v is equal to u plus a t. So simply substituting the values, v is equal to initial velocity u is 0 plus a into t. A is 2, time is 5, that is 10 meter per second is the final velocity. For second part, they have asked us to find the distance traveled. So again, this time we are going to use the formula v square minus u square is 2as. We have to calculate s, so we can modify the equation as s is equal to v square minus u square upon 2a. Putting the values, we have calculated v, that is 10, so 10 square minus initial velocity is 0, so 0 square divided by 2 into a, that is acceleration is 4. So that is 10 square is 100 minus 0 is still 100, 2 into 2 is 4. So therefore the value of s, or the distance, is 100 divided by 4 is 25 meter. Now we go to the next question, that is question number 5, which says a bullet initially moving with a velocity of 20 meter per second strikes a target and comes to rest after penetrating a distance 10 centimeter in the target. Calculate the retardation caused by the target. Here we just need to convert this distance, that is 10 centimeter, into meter first, and then we can use the formula v square minus u square is 2as. So here we write the given things. Initial velocity here, initial velocity u is nothing but 20 meter per second. Finally it is coming to rest, so final velocity v is 0. Distance that it penetrates in the target is distance s is 10 centimeter. So 10 centimeter, if I have to convert it into meter, that would be 10 divided by 100 meters. So 10 divided by 100 meters is 0.1 meter. Now using the formula v square minus u square is 2as, we know v is final velocity, that is 0, so 0 square minus u is 20 square is equal to 2 into a, we have to calculate, and distance is 0.1. So for this we will have minus 20 square is 400, 2 into 0.1 is 0.2, coming this side it would be 0.2 will come as divide, and the acceleration. So acceleration is, if we divide, we will get you remove the point, put a 0, so 2000, and this minus sign, meter per second square. The negative sign indicates retardation, so we just write the negative sign indicates retardation. So the answer is 2000 meter per second square. Now we try solve question number 7. Question number 7 says, a train travels with a speed of 60 km from station A to station B, then comes back with the speed of 80 km per hour from station B to station A. Find the average speed and the average velocity. So let S be the distance between station A and station B. So the total distance is S, that is the distance between A to B, plus again that is 2S, and we calculate the total time. So from A to B, time is given as distance by speed. So distance is S, and initially when it's going from A to B, the speed is 60 km per hour. Similarly, from B to A, time taken would be, distance remains S only, but the speed has increased to 80 km per hour. So total time would be addition of these two. So S by 60 plus S by 80, that is equal to, we take the LCM, 60 into 80 is 4800. So 60S plus 80S is nothing but 140S. Now for the first part, we have to calculate the average speed. So average speed is equal to total distance upon total time. So total distance is 2S divided by total time is 140S divided by 4800. So this will go up, S and S cancel out. So our equation looks something like 2 into 4800 upon 140. 776 48, and then it would come to 480 upon 7. So that would come around 8.5, let's say 68.5 km per hour. And the second part of the question says, what would be the average velocity? So in this case, average velocity would be 0, because the displacement is 0. The train is coming back finally to station A itself from where it started. Now we go to the next question, that is question number 8, which says, a train is moving with a velocity of 90 km per hour. It is brought to stop by applying the brakes, which produce a retardation of 0.5 meter per second square. We have to find the velocity after 10 seconds and the time taken by the train to come to rest. So here we write the given things. The initial velocity, that is u, is 90 km per hour. Here it's given. if we convert it into meter per second, we will multiply it with 5 by 18, so it would come to 25 meter per second. Then finally the final velocity as it is coming to rest is 0 meter per second, and acceleration is here. They say that the retardation produced is 0.5, so acceleration is minus 0.5 meter per second square. Now we have to calculate the velocity after 10 seconds. So case 1, or the first part of the equation, we just write that let v be the velocity at t equal to 10 seconds. Now if that is the case, we are using the formula v equal to u plus at. That is the first equation of motion. Applying this, the value of v is u, or u is here 25 meter per second. So 25 plus acceleration is minus 0.5, that is the retardation, multiplied by the time, that is 10 seconds. So after solving all this, 25 plus into minus is minus, 0.5 into 10 is 5. So we have 25 minus 5, that is 20 meter per second. That is the answer for the first part. Now the second part of the question, where we have to find out, it says that the time taken by the train to come to rest. So here we say that let t prime be the time taken by the train to come to rest. If that is the case, again we use the equation using v equal to u plus a, time is t prime. So we can write the equation in terms of t prime. So this implies t prime would be v minus u upon a, that is the acceleration. So final velocity is, we have just calculated, 20 meter. So 20 minus, sorry, the final would be 0 because it's coming to rest, minus the initial velocity is 25 meter per second, divided by the acceleration, which is the retardation actually, so minus 0.5. So minus and minus will cancel out, and we will have 50 second as the answer. Now we come to the next question, that is question number 11, which says a body moves from rest with a uniform acceleration and travels 270 meter in 3 seconds. Find the velocity of the body at 10 seconds after the start. So here the things that are given to us is the initial velocity given, initial velocity, that is u, is equal to 0 meter per second because it starts from rest. Distance s is nothing but 270 meter, and the time t, they have given it to be 3 seconds, in 3 seconds. Now using this we can calculate the acceleration. So using s is equal to ut plus half at square, s is given to us 270 is equal to ut. Initial velocity is 0, so u into t, this whole term becomes 0, plus half into a we have to find out, and time square, that is 3 square, that is 9. So acceleration would be 270 multiplied by 2 divided by 9. 60 meter per second square. Now we assume that let v be the velocity of the body after 10 seconds. So if that is the case, 10 seconds after the start, so in that case, using v equal to u plus at, we can find out v is, initial velocity was 0 because it's starting from rest, plus acceleration is 60, we have just calculated here, multiplied by time is 10 seconds. So 60 into 10 is 600 meter per second. That is the answer. Now finally the last question, which states that a spacecraft flying in a straight course with a velocity of 75 km per second fires its rocket motors for 6 seconds. At the end of this time, its speed is 120 km per second in the same direction. We have to find the average acceleration while the motors were firing, and we have to find the distance traveled by the spacecraft in the first 10 seconds after the rocket motors were started. And we have to note that the motors having been in action for only 6 seconds. So here initial velocity given, initial velocity u is 75 km per second, 75 km per second. Final velocity v is 120 km per second, here it's given, and time is 6 seconds. Now the first part, we have to find the acceleration. So acceleration produced would be final velocity minus initial velocity upon time taken, that is t. So we simply write final velocity is 120 minus initial velocity is 75 divided by the time taken, that is 6 seconds. If that is the case, 120 minus 75 would be 45 divided by 6, so that would come to around 7.5 km per second square. Now for the second part of the question, which says that distance traveled, we have to calculate distance traveled by the aircraft in first 10 seconds. So that is equal to the distance traveled in first 6 seconds, that is given in the question. We will mark it as S1 plus the distance traveled in 4 seconds. we will mark it as S2. So total distance S is equal to S1 plus S2. So to calculate S1 and S2, that is S1 is equal to, S1 is the distance in the first 6 seconds. We use the formula ut plus half at square. So u is 75, time is 6 seconds, plus half acceleration is, we have calculated it to be 7.5 multiplied by time again, square of the time, that is 6 square. So 5 into 6 is 30, 450 plus half 7.5 multiplied by 6 square, that is 36. So if we calculate it, it would come to 450 plus 135. If we add it, it would come to 585 kilometer. Now we calculate S2, that is the distance for next 4 seconds. So that is speed multiplied by time. The speed is 120 kilometer per second and the time is 4 seconds. So if we multiply, it comes to 480 kilometer. So therefore total distance is S1 plus S2, that is 585 plus 480. It would come to 1065 kilometers. That's all. Thank you so much.